Impulse. State the impulse equation in words. What is impulse? What is this? Well, it's given by these two equations. Impulse is the vector sum of the forces multiplied by delta t. Okay, that's the equation, but what is it? Remember that if we have a system, we could have objects inside the system interacting. As long as there's no external forces being applied to the system, then we know that the momentum, delta p, doesn't change. Okay? But if there is an external force being applied to the system, then we will have a change in our momentum. And essentially the change in momentum is your impulse, delta p. Delta p is your impulse, your J, which is your change in momentum, which is simply the sum of the forces applied on the system, the external forces, over a specific time period. And this is the equation for a constant force. Okay? So a force that looks like this, say Ft, a constant force, right? 10 newtons, 100 newton, whatever. And this is the same equation, but it is for time varying. So if your force, say, was increasing over time, or it was decreasing over time, or it had any other kind of time varying, it was some function of time. As time goes on, F changes. Okay, then you need to integrate Ft dt. You need to integrate this. So this is for non-constant, a time-varying force, and that's for a constant force. 25. Suppose that one or more of the forces exerted on an object is not constant, but that you have information about each force exerted on the object, how each force exerted on the object varies as a function of time, during the time interval. How can this information be used to compute the impulse? Well, we would just use this integral, okay, in a very simple way. I'm not going to do any examples here, but whenever your force is not constant, we integrate, okay? System of two interacting objects. What distinguishes an internal force from an external force? Okay, so this depends on your system, how you've defined your system. If you've got two objects interacting with each other, okay, and you have defined your system like that, that means both objects are within the system and that both objects are applying equal and opposite forces, okay, then that means those forces are internal to the system and they cancel out in the system. Okay? So, those are internal forces. However, if you take that exact same object, let's use this right-hand one, and we make that object our system, then can you see this object's force being applied is now external. Whereas before, that force, because it was included in the system, was internal and they cancelled out. Now it is external to the system. That's how you distinguish internal from external. Explain, 27, explain what is special about the motion of the center of mass. The motion of the center of mass of a system made up of two interacting objects when some external force is exerted on the system. Okay? Remember, for every system of objects, even if it's a single object, multiple objects, and there's my system, every system has a center of oh dear, sorry, has a center of mass somewhere. Okay, looks like this, right? Am I drawing it right? Something like that. Every system, the universe has a center of mass. Your body has a center of mass. Every system has a center of mass. Now, what is special about the motion of the center of mass? If there's some external force. Okay, let's go here. Let's just open up a new one. Okay, so remember, if we've got a center of mass, and that's my system. If this is an isolated system, then remember that the center of mass the velocity of the center of mass remains unchanged. Remember, if there's no external force, then the center of mass, the velocity of the center of mass does not change. However, if there is some external force, then the velocity of the center of mass changes. Remember, F, sum of the forces is mass times acceleration. Okay, for a single object, that's easy. We just have that's our object, and that is our system. And so a force being applied to it is an external force, and what it does is it accelerates that object. But what we're really saying is that it's accelerating the center of mass of that object. Similarly, if we have a system of objects, then an external force is going to accelerate the center of mass. Okay? It's going to accelerate the center of mass. If there's no external force, then the center of mass, the acceleration of the center of mass is zero. Okay? Even though these objects are interacting within the system. Okay, I hope you get that. So what was the question? I think that's the question. What's special about the motion of the center of mass? When an external force is applied, it accelerates. It accelerates. Okay? 28. What is the numerical value of the vector sum of all internal forces exerted in a system composed of many objects? What's the numerical value of the vector sum of all the external? What's this value? The vector sum of all internal forces. Well, we've seen the internal forces just cancel out. If you add them all up vectorially, meaning you take into account their direction. Remember, if you say that vector plus that vector, if they're the same length, that vector plus that vector gives us 0 vector, right? So what is the numerical value of the vector sum? It's 0. 0. Okay, I think that's okay. Try and do that last one. Try to do this last one on your own. Cheers.